Okay, hi everyone. I will advise to try to be as close as possible from stage because I have some doubts about like the code example I'm going to share. I'm going to try to make them as big as possible, but I'm unsure it's going to be easy to read from far. So let's get started. Okay, sorry. Okay. So hi everyone. So my name is Charlie. I'm from France, Paris. So I apologize in advance if my accent sometimes is a bit hard to understand. And so I'm working as an open source software engineer at the Guild. And the Guild is a collective of open source person and a company that's been here like for 10 years. And in the past 8 years, especially working on the GraphQL ecosystem. So if you're doing GraphQL, you might have heard about like GraphQL code generator, GraphQL tools, GraphQL scalars, and there is 5 or 6 other big projects. And because of our expertise on GraphQL, the White Queen came to us to share some insights regarding a GraphQL prophecy about the future of GraphQL. So while this prophecy is covering the whole GraphQL ecosystem, which is like, front end and back end and sometimes a bit more, today we're going to focus on APIs. And here's the reason why. So, as you may know, GraphQL has been publicly released in 2015 by Facebook and was initially aiming to reduce the frequency and the amount of data being exchanged between the client and the server by exposing this new language that allows you to express rich data requirements with nesting and without limitation. And also allowing you to express what you really need and not getting all the data that, for example, a REST API could give you. And this led to a lot of front-end innovation because very rapidly some open source person and company realized that a lot of things could be done with the schema that is typed. And the first thing that arrived was like normalized cache on the front end that is not like very with thread and has been replicated in known GraphQL libraries such as React Query, and also end-to-end type safety because it's very easy to generate TypeScript types from GraphQL types. And also this led to a lot of innovation in UX pattern with like optimal cache optimization, etc., etc. So while the first years of GraphQL were really focused on front-end innovation, in the past years, there was like a change of focus on moving to the back-end. And in 2022, GraphQL is a recognized solution for microservice orchestration, or as we say in GraphQL, gateway or federation sometimes. And this led to a lot of SaaS companies building tools that helps to be faster at building GraphQL API, having like a very fast scaffolding, but also building faster GraphQL API with caching solution at edge. Or just simply, the most famous right now is everything around schema registry. So it helps you to manage all your GraphQL API in your gateway. But 2022 is also the year of the first edition of the State of GraphQL. Like the State of GS, but dedicated to GraphQL. And this highlights that GraphQL now is a very rich ecosystem with a rich community that goes beyond JavaScript itself. And there is now many flavors to tackle a specific subject of GraphQL, like schema design or different API server library. But while the ecosystem is right now focusing on pushing the boundary of GraphQL, the White Queen reminded us that GraphQL is first and foremost a technology for developer, for great developer experience, and that many things we're still missing and need room for improvement on just building, if I can say, simple GraphQL API. So today we're going to cover this subject of simple GraphQL API, as we can say, standalone versus gateway, and with the GraphQL prophecy. So let's take a look at this prophecy. And like every prophecy, it's very simple to read, and there is easy steps. So the first one is like, the White Queen said that in the future, modern GraphQL APIs library should empower developers. It should make easy to access GraphQL best practice. And also, modern GraphQL API libraries should make easy to finally build real-time application over GraphQL, which has been a promise that has been here since the beginning of GraphQL. But most of us, developers, are struggling to really put it in place. And finally, the prophecy ends with saying that modern GraphQL API should run everywhere, anywhere. Because it's the case right now, you can do GraphQL in Go, in Java, in a lot of languages. But when it comes to JavaScript, it's still right now really focusing on Node.js. But the JavaScript ecosystem is moving very fast, with Cloudflare Worker, with Edge function on Vercel, and also new runtime. And how do we make sure that we can join this party also and not stay blocked, on the Node.js land? So we at the Guild took this GraphQL prophecy very, very seriously, and we decided to, for the next major, to apply all this vision into concrete library that you could use and to realize this prophecy, to change the life of all the developers that build API, but also to the people that consume those modern APIs. So in this presentation, I will go over the different parts of the prophecy with examples that are actually working today using this library, but also others library like Apollo Server or Mercurius. So first, let's talk about the future of GraphQL API that empowers developers. So we're going to take a look at 3 parts of best practices and things that library should empower developers to better handle and better handle. So the first best practice that we're going to talk about is about error handling, because error handling is not necessarily as straightforward in GraphQL. There is many ways, because the ecosystem is rich, so there is many practice. So we're going to cover 2 main practices, so you have it in mind and you see clearly how to put it in place in your GraphQL API. Then we're going to take a look at security. So compared to REST, it's not as simple to really understand all the mechanism around like securing a GraphQL API. And we'll see that in the future, it should be easy. You shouldn't need like a PhD or knowing all the spec of GraphQL by heart to be able to secure it. So we're going to see that it's going to be easy to achieve. And finally, on top of those very core aspects of any kind of API, we'll see that nowadays it's still hard, for example, to apply very common pattern of any kind of API to GraphQL, like caching, like logging, like handling file uploads, etc., etc. So let's talk about error handling. So in a GraphQL API, so all the examples will be in JavaScript. Sorry if you're not doing JavaScript. So you are mapping your resolver, which is just a map with a set of functions, to your schema, queries, or mutation. And here we have a query which is making a data to another API to resolve the data. And with most default GraphQL API library setup, the issue is that if you are failing to reach the other API, the error is going to bubble up to the result, leaking, so not leaking the stack trace, but at least leaking the error message, which is like for here, the address of the other service. And this is not necessarily the kind of information you want to leak to the end user when you are running like production GraphQL API. And the main issue here is that like this error, for example, is going to be thrown by fetch, which is like a native API now in most runtimes, extending the error class of JS runtime. And if you are throwing like domain-oriented, like business, like a real error, GraphQL is going to handle it in the same way. So there is really no way to say, okay, there is some errors I want to provide to the users, and there is some errors I want to keep to myself and just say to the user, something happened. So a modern pattern in GraphQL API that you can find in Yoga, but also in Apollo, is error masking. So error masking is the principle that your GraphQL API library will, by default, not mask all information about an error that has been raised in the resolving step of a request. So here, what was previously like leaking a lot of information is just saying, okay, we didn't fulfill your request, and we're going to look into it. But what happened if you really want to provide, like a descriptive error scenario? Then you're going to refactor your code and not use the error from JavaScript and use the GraphQL error class from the reference implementation GraphQL package, which is just extending the error class from JavaScript, but with more information. And then this error, when thrown, will provide a proper error to the end user. So this is the first recommendation and something that you can already put in place today, very easily. So one thing also to note, which is interesting, so if you're doing GraphQL, you might already know that, but so GraphQL is very, very, very following the HTTP spec, which is like a path, a dedicated path should not return something else than 200. So if, how to say that? So in REST API, for example, if you have like API/user/1 and the user does not exist, it's going to return 404, which is not really, you know, spec compliant per se. So GraphQL is a bit more spec compliant by saying that the GraphQL endpoint will always return 200 OK, even if the state of the request that you are providing to the server is an error. The only scenario where the GraphQL API will return not a 200 is like 400 bad requests because some parameters are missing, or 500 because the application crashed. So maybe some of you do not agree with this, which is fine, and you want to return a 404 if, for example, you don't find a user. So this is possible. With error masking and using the GraphQL error, you're just providing extension and using this configuration pattern, providing a HTTP status, and this HTTP status is going to be forwarded to the end user. So let's now talk about something that is less specific to GraphQL API libraries, but more about how you define your schema, but still related to GraphQL error. So now we have like nice, safe GraphQL errors. But the issue is that normally, for all implementation, the errors are being sent in the error key of the response and not in the data. But one of the reasons we're all using GraphQL is because we want type safety. So the issue is that when you have errors, you are losing all type safety. You're just having data null, and you will never get TypeScript equivalent of what could arrive in the errors key, because it's not part of the introspection spec of GraphQL. So there is another practice, modern practice in GraphQL, which is leveraging fragment to provide typed error information to your end user. So here we can see that we are doing the user query, and if the request succeeds, we're going to be inside the first fragment on user, but if we cannot find the user, we're going to fall back to the other fragment, which is user not found error. And the big advantage of this solution is that you are really leveraging all the power of GraphQL, which is like end-to-end type safety and a very descriptive way of exposing all kinds of scenarios. So implementing such thing is actually quite easy. The only thing is that you have to refactor a bit your schema. So this is a GraphQL schema. And instead of returning a user, you're going to return a union of different scenario. So the best case scenario, which is I find your user, is going to be a user. And then you're going to pipe it with the union operator to the different other scenario. And the implementation itself, so if you're doing TypeScript, this is going to remind you what we call the pattern that is called like a discriminant union, also like tag union, which is like GraphQL is going to be able to identify which kind of type is going to be returned, depending on the common property between the user type and the user not found error type, which is the type name property that is like in every type in TypeScript. So here, in our resolver, instead of throwing an exception, what we're going to do is that we're going to return a user. So here you can see what I was talking about, the type name __ type name. This is how you say to TypeScript that your resolver is resolving to a given type of data. So here, you can see that also the resolver implementation is not that complicated. And by doing so, you're having like error masking because you're not leaking sensitive information to the end user, and you're providing like end-to-end typing. So if you are building a new API, you should definitely consider it. And if you are refactoring your API, you should consider it also. OK, so just to sum up on this part, when it comes to error handling design in GraphQL, please, if you want to stay with exception-based error handling, please enable error masking. And if you can actually refactor your schema, please consider looking at fragment-based error design to provide end-to-end type safety to your consumer. So let's now talk about another thing that we could do to empower developers. Better tools to actually have the best practices on security. So why security is a challenge on GraphQL? Because GraphQL is like, it's awesome, but also way more complicated because people can request a lot of things and express a lot of different things in GraphQL. And it's a bit sometimes unpredictable. And this comes with two main challenges. First, GraphQL at its core is introspectable. So you can send an introspection query to get a description of the schema. So this is easy to disable for production, but we're going to see that there is another feature of GraphQL that is the exploration of the schema, which is not something you want to have in production. People exploring what could be the different type, etc., etc. And finally, the query language itself is like very declarative, very expressive, so people can tend to say, okay, so it's nice, it allows me to get more data than the REST API. So give me the list of 1,000 products, and for each product, give me the collection, and for the collection, give me another object. And then you end up having like very long query, not necessarily like a DDoS situation, but hard to handle situation because it's unpredictable how people are going to use your API. So let's take a look at the first, yeah, the contrast is good. First example. So what I was saying is that like in GraphQL, if you make a typo, the GraphQL execution engine, not your resolver part, like really the core of GraphQL library, is going to try to help you and say, hey, you try to look for a field that is called Pokemon, but actually I know something that is called Pokemon. So it's nice, but in production you might not want to have that, because if someone makes a script and start to send requests, this is going to reply super fast, because it's not even reaching the resolver part, it's stopping at what we call the parsing and validation phase of the GraphQL execution layer. So this can be quite easy to automate, to try to guess what is your old schema, depending on the application you are building. The other security challenge, like I said, is unexpected large query. And there is two issues with that. The first one is at the parsing phase and execution phase. What happens if someone sends you a multiple megabyte query that does a lot of references, and your server spends a lot of time just even trying to parse it? So this is not good. You want to put something in place to avoid that, especially if you expose a public GraphQL API. And the same thing happened. So the example I was saying earlier, it's better with an example, even if it's a bit small, sorry. So you could have the issue at the execution level. Someone could try to get too much data. And if you don't implement the proper pagination, or if you're not making sure that a very expensive field to resolve is protected or cannot be queried outside a loop, your server might end up computing a lot of things. Sorry. So the good thing about that is that, so in Yoga, we followed like those principles of like what could we do to make the life easier for developer in the future, and we developed a plugin system, and one of the plugins is called Envelop Armor, that you can configure very easily just with a one-liner, and it will enable the best practices security rules for your GraphQL API. So as you can see here, we are configuring a server, and we are passing it into the plugins. So the first thing is that it's going to do parsing protection. It's going to limit the number of aliases and the number of characters that are in the request. It's going to do some protection at the execution, allowing you to configure some cost limit and saying, by default, for example, it's going to apply default configuration that says, okay, so by default, retrieving a scalar is 1 point, retrieving an object is 2 points, retrieving a nested object is multiplying everything by 1.5, and a query should not be above 5,000 points. And this is the default, but you could say, oh, okay, this specific field, user.SSO's configuration that you have to fetch somewhere else, this is actually 100 points. So you're making sure that even at the validation phase, it will never reach your resolver, so your actual application, if it does not match those criteria. Same with depth limit. You want to, most GraphQL application will allow you to maybe do 2 nested field maximum, and this is going to be the default configuration. And finally, it's going to disable the field suggestion that we saw. So by default, in production, you won't have like, oh, you had a typo, maybe you meant something. Okay, so we just saw that now it's easy to have secured GraphQL API without knowing everything about the different spec, etc., etc. And it's configurable. Let's now see like all the core features of APIs, features that you find everywhere. So nowadays, for example, configuring cores or allowing file uploads or doing caching, LCL, tracing or tracking is not that easy in GraphQL. It's not a one-liner, and sometimes it requires additional package, most of the time. So for example, historically, most GraphQL API library don't provide any API to configure cores. They are saying to you, we are executing GraphQL queries. If you want to configure cores, you have to do it at the server level with Express, etc. Or you require another package that we made that's going to help you configure cores. But like the prophecy said, like it should be easy. It's something that we all need to have, especially right now when we have a lot of microservices, and most of the time when your front end is hosted on a different, at least port locally, and domain in production from your API. So Yoga by default is going to say, okay, cores is disabled by default, which is the contrary of all the library that enable cores by default and don't allow anything. So the first thing that you have to do when you do GraphQL is actually to configure cores, because even locally, it's not allowed properly. And then, with very simple configuration, you'll be able to configure cores at the Yoga instance, Yoga application level, and this cores configuration will be forwarded to the server that receives the Yoga instance. So I will show you example of that in the last part of the presentation. Another subject is file uploads. So most GraphQL API libraries, server libraries, don't support file uploads, which is a bit weird because when you're building an application, it's very likely that you will at least need to upload the avatar of your user or something like that. So now, it's true for Yoga and for Apollo server, which is the more widespread GraphQL server implementation. You just have to define the Scala file to use it in your mutation, and then it will handle file upload in your GraphQL API automatically for you, like an opt-in, built-in mechanism to have file upload. And your resolver will receive a file of a type file, the type file not from the Node.js type, but from the fetch API spec one. So like I was saying, some things are harder to set up because, for example, when you're doing ACL with REST, you can do it by resources, you can do it by endpoint. And with GraphQL, it can be a bit more complicated because the query came in different form and it does not necessarily match your underlying resources or data model. Same with caching. GraphQL is very sometimes compared to graph kind of way of expressing things. So caching applied to graph can be a bit complicated. Same with monitoring. If you put monitoring and look, okay, I'm going to track what is the performance of the /GraphQL endpoint, it's not going to give you anything because the /GraphQL endpoint just receives all the queries. So it's not going to give you a nice representation of what is the actual performance depending on the usage of your GraphQL API. So all those things led to us building, and Apollo also has their own plugin system, a set of plugins that we call Envelop that provide you plug-and-play solution to get started very quickly and configure it and extend it for your needs for all those very core features that you need in any kind of modern API, whenever it's GraphQL or not. So you'll be able to do caching, SCL, etc. So here is an example with caching, with the plugin that is called Use Response Cache. So you're going to say by default, all operations are cached for 2 seconds. You can also put a TTL by type, by field. So this is what we call coordinate. In GraphQL, coordinate is the combination of a type and a field, or multiple one, nested one. So as you can see, it's really easy to get started, and like for the security plugin that we saw, you can enable it by default, and you will have like strong default, best practice default for you on caching. Okay, so now we saw how we could in the future make the life of developers that want to build GraphQL APIs easier. Let's take a look at real-time. So real-time has been here since the beginning of GraphQL, because in GraphQL you have 3 types of resources, operation that you can expose. You have like queries to get data, mutation for the create, update, delete, and you have subscription that allows you to say, okay, I want to subscribe to update on an event. The issue is that like since the beginning, subscription has been really advertised over WebSocket. And if you want to do subscription, you really have to set up WebSocket in your application, on your server, on the front end, and have everything to do that. So, and this requires additional package, configuration, and even like infrastructure, depending on how you're running your application. And finally, another feature of GraphQL is stream. So I'm going to showcase after what is it, and stream is a different kind of subscription that you can do at the field level and not at the operation level. And this feature has been like advertised in conference like for almost like 5 years now, but you won't find any library that allows you to do it, to actually use it in production or even in development. So we're going to talk about that. So just to illustrate a bit what I was talking about, on the right you'll see that 80% of the code here is dedicated to instantiate and configure your WebSocket server so you can expose subscription. And 20% is just going to be import in a regular GraphQL API. So the issue with WebSocket, we think, and as a blocker that does not enable people to actually build real-time APIs, is that you have to use external dependency, you have to do more setup, and you have to deal with WebSocket, which is a bit different also on the front end when you want to work with it. You cannot really inspect it in the same way like request, you know, that you are sending, HTTP request you're sending to the server. So what could be the solution here? So we thought that the solution here is to put back to life something that is a bit old from the internet, but still here and supported by our brother under the HTTP specification, which is server-sent event. So server-sent event is a very specific type of request, HTTP request that you send to your HTTP server, your GraphQL server, and this connection is going to keep kept alive, and the server is going to send update in a one-directional way and not bidirectional way like WebSocket to your client. So the good thing is that it's part of HTTP. It's well supported by all browsers because it's a very old part of HTTP and stable one. It's supported by default with Yoga. With Yoga, you don't have to do anything. You want to do subscription, by default it will be over SSE, and you won't have to configure anything. Here you will just have to provide like any kind of other API, just your schema, your resolver, and your resolver that are actually subscription will be leveraging the generator pattern of JavaScript in order, to be called multiple times and return like real-time result. And it's also supported by most GraphQL clients, the server-sent event. So we really think that is this providing that subscription over SSE is a very good first step to make sure that people can give a try, to subscription and building real-time application using only GraphQL and not opening their own Socket.io server besides, GraphQL and dealing with 2 different type of code base. And yeah. Let's see another thing. So I was talking about stream. So here, for example, on the right, you have like a blog post query, and let's say, for example, you have your blog and you want to display a blog post, but you want that the comment display in lifetime because you are very successful and popular. You're sure that a lot of comments are going to happen in real time. So how can you do that with subscription? If you want to do it with subscription, you will have to subscribe to the blog post and receive every time all the blog post and the comment, etc. So it's going to be very like compute intensive because every time like you will have to re-resolve all the blog posts and send everything and resend all the comments, etc. So another feature of GraphQL is stream. So add stream is a directive that you can put on a specific field that should be an array. And what's going to happen is that GraphQL is going to send you the blog post, it's going to send you the initial comment array that it has at the moment you make your request, and then it's going to open a SSE, like a request that's going to stay open with the GraphQL server, and it's going to send you only the new comment for this specific blog post. And on the client side, your request will be updated in the cache with the new comment as they arrive. So there is many advantages here. It's very expressive, it's very simple to use, and it's very performant, because you are only updating what you really want to have up to date. So again, stream also work over server-sent event, and it's supported by Relay, which is the GraphQL client from Facebook, and Yourcall, the GraphQL client from Formidable Labs. So let's talk a bit more about SSE and a bit less about real-time, because there is another feature of GraphQL that has been waiting, that everybody is waiting for years, and that can be achieved over SSE, which is defer. So defer is aimed to solve like incremental delivery. So because what is the problem with GraphQL when you express two big requests? Here, for example, we want to get a document. So it's a kind of, let's say, like a Trello kind of application. We want to load a document, but the issue is that getting the assignee is pretty fast, title, etc., but getting the tags is a bit, for, let's say, technical depth reason, it's a bit slower. The issue is that the GraphQL server is not going to return the response until it gets the data for all the fields that you requested. So if one field is slow, it's going to impact all the performance and the duration of your GraphQL query. So this is where defer come to place. So defer, it's a directive, like stream we saw earlier, that you can apply on fragments, so inline fragment or this kind of fragment usage. And what's going to happen is that it says to the GraphQL API, you can send me the data as soon as you have all the fields that are resolved except the one that is annotated with defer. So as soon as your API will get the assignee, the title, and the ID, it will return the data, and then once it will resolve the tags, it will send it in a second part in another HTTP request as part of SSE. So on the right, you see what will be the difference. It allows you to build like more progressive application where you can actually more rapidly display information to the user without impacting the overall performance. So this defer and also stream and subscription are all features that you can really start to use today with Yoga as a server, but also with Apollo router for defer, not for stream, using server-sent event. So it won't require much change in your current application or even infrastructure, depending on your traffic, and it's supported by all GraphQL clients. So as you can see here, like for file upload, it's an opt-in feature. You have to import a plugin and say, okay, I want to enable the support for defer and stream in my GraphQL API. Okay, so let's sum up before going to the last part. So real-time should be easy because it's easy to set up and you don't need additional configuration or transport. You should delight your consumer, so your client, by delivering all the data and even the live one through GraphQL and not different like technology, like using Socket.io for live data and GraphQL for the rest. And you should also delight your user, because by leveraging such features like defer and stream, you are providing like better user experience in the edge. So it's a win-win for everybody, for the person that writes the API, use it, and also for the end user of your application. Okay, so let's talk about this last section. It's a quick one, and I'll let you have lunch. So the future of GraphQL API is also API that should run anywhere. And like I said earlier, most JavaScript GraphQL library are focused on Node.js. They work super well in Node.js. But as soon as you want to run it somewhere else, like on Cloudflare Worker, on Vercel, use it with Dino or Bun.js, it's either not working, supported, or you have to really install a lot of package and do a lot of configuration to make it actually work, because it's not made for it initially. But the thing is that right now, JavaScript is really changing at a very fast pace. Like a lot of people are using GraphQL Worker and not necessarily AWS Lambda, and those runtime are not providing all the APIs of Node.js. So you have to have library that can work with different, for example, that support like the fetch implementation. It does not depend on the Node one by default. And same comes with supporting like Dino or Bun.js. So why GraphQL developers should not be invited to this party of new technology? So we took, again, this very seriously, and the architecture of Yoga is the following. You actually define your Yoga application, what we call, which is a combination of a schema and resolver and some plugins that we saw earlier to change the behavior of the execution, and you get your Yoga instance. And the thing is that your Yoga instance can be then reused to be deployed in different environments. And you don't have to rewrite every time your application if you want to deploy it to GraphQL Worker, if you want to use it on Bun or Next.js functions, etc., etc. So we think it's a game changer, because running everywhere with an easy setup, you have a single package for all environments, you have portability, you can share your application between all server implementation, and it runs everywhere, from Lambdas to Bun.js. Okay, so let's wrap up about the future of GraphQL. So it's important that we have like a great developer experience, easy access to best practices, because not why we are making things very easy for people that consume GraphQL, the client, the front-end and mobile developer, it gets a bit harder for the back-end developer. It shouldn't be. So it should be easy to have the proper error handling best practices. Security, file upload, caching, everything we saw. Same, real-time, GraphQL should finally be the unified solution to query any kind of data. Either it's like one shot, if I can say, data, or real-time data. And finally, you should be able to run your GraphQL API everywhere. I just say it, so I'm not going to say it again. So I hope you enjoyed this presentation and this look at the future of GraphQL. You can already take part to this adventure with GraphQL Yoga or other implementation, Apollo Server or Mercurius. You can, if you're interested in learning more about GraphQL and also what we do at the Guild, because we do a lot of different solutions, this is just one of them. You can go to theguild.dev, especially on the blog, plenty of resources to learn things about GraphQL. And thank you very much.